Good morning. Today we're going to be talking about one of the really important concepts in forces, which is friction. So a little review first. A force is a push or a pull. They have direction and size, and we use newtons as the basic units for force. When all the forces on an object are added together, we get net force. If you have a net force of 0, which means all the forces are balanced, then you will not change your motion. Only an unbalanced force can change motion. So for example, this person here is sitting in a chair. They're pushing down on the floor and the floor is pushing up. These forces cancel each other out and therefore they are balanced. There's no change in motion. This person will probably not be moving. Now, if the forces are going in the same direction, you add them together to get the net force. So these two people are either pushing or pulling on a piano. And if we add the forces together, 20 and 25 newtons, we get a total of 45 newtons to the right. This assumes that there is no force opposing them, which is what we'll talk about today. If the forces are in different directions, you subtract the smaller one from the larger one. So the big dog is pulling with 12 newtons. The smaller dog is pulling with 10. So it's going to be 12 minus 10. The net force will be 2 newtons going toward the right. As you can probably predict, the big dog's going to win. Only an unbalanced force can cause the change in motion of an object. If all the forces are balanced, it will either not move at all or it will continue moving at whatever speed it was moving at before, but there will be no change. And now, one of the forces that makes something unbalanced, friction.
Say, Wilson, could you pass me that book? Say, Wilson, could you pass me that book?
Now, what causes friction? It's a force, and the force always opposes the motion between two surfaces that are touching. So whatever direction you're moving, friction is moving in the opposite way. Although most things look like they might be smooth, they actually have very rough surfaces with lots of divots and valleys and hills. And when they come in contact with each other, they stick together. They get these what we call micro welds. You could shrink down to the size of atoms and see even two really smooth things next to each other. You'd see that they're not smooth at all, and this is why it's hard to get them to move. Even something as smooth as glass under a microscope, an electron microscope, reveals that it's not nearly as smooth as it feels like to our hands. So what causes friction? The amount of friction depends on the roughness of the surface and the force pushing down on the surfaces. So smooth surfaces have less friction, and if you apply a force, you will get more friction than if it's lightly done. Now, friction can be pretty important. It's something that we depend on. It's hard to actually walk. It would actually be impossible to walk without friction. You hurt yourself if you try to even walk on ice or try to brake. Braking would be impossible without friction. Putting on the brakes is creating a friction between the brake pads and the tires. That's why the tires stop in the first place. There's different kinds of friction. There's basically 4 different kinds of friction. The first one is called static friction. Static friction occurs when you have something that's sitting still and it's creating these little micro welds there. And to get something to move, you've got to break static friction. And that's not easy because static friction is actually the strongest of the frictions. It's the reason why you may have noticed when you try to move something, it's really hard to move it at first. And then once you get moving, it's easier. But if you come to a stop, you have to work hard again to get it going. So here's my friend, actress Emily Vassilos, and she's trying to move a pretty heavy object. Now, once she gets it going, it goes pretty fast. But it was hard to get it going in that beginning because she had to break the static friction. Now, once you get it moving, we're now into the second kind of friction, sliding friction. Sliding friction is a strong friction. I mean, imagine trying to slide a car, push a car that had no tires. That would be sliding friction. It's strong, but it's not as strong as static friction is. It's sliding friction that caused that book to stop moving. Now, people figured out pretty early on that the wheel was a really effective way to reduce sliding friction. Putting wheels on something made them much easier to move than they were without the wheels. Now, why does this work? If you look at a wheel, it's not really touching the ground in a very large area. only a little tiny part of the wheel is actually touching the ground. So that's one reason. The other is that rolling is just a less frictional way of getting something to move. If you were ever in a situation where it was an icy road outside and you had to drive, you just could not avoid driving, one effective thing to do would be to let some of the air out of your tires, so your tires kind of get a little bit flat, and therefore they're gripping the ground more. Now, if you're going on a long trip, you want to do the exact opposite. You want to inflate your tires as high as they can possibly go so that only a little bit of the tire is touching the ground. That's going to give you much better gas mileage. Here, Emily is moving the same thing, the same heavy object she had before, but this time she is rotating it on its edge, kind of like having a wheel. And although it's slow going, it's a lot easier. Now, put it in a wheelbarrow, and now you're using rolling friction to its full advantage, and it's much, much easier to move things around heavy objects than it is dragging them. The weakest kind of friction is what we call fluid friction, and fluid refers to either liquids or gases. They although they do oppose motion, they just don't do it as effectively as the other kinds of friction. So you'll notice that you can drag something pretty heavy through the water that you could never drag through the street. So to reduce the amount of friction, we can put a lubricant, something that will grease it up, wax or grease, and these will reduce the contact between the different objects. It's one reason why you have to change the oil in your car, because all those parts of the engine moving around, rubbing against each other, they create a great deal of heat. And if you don't keep it lubricated and let them reduce the friction a bit, the amount of heat will be great enough to break the engine. So if that oil light comes on, change it. Okay, don't do that. If you want to increase friction, and sometimes you do, you make the surfaces rougher or increase the force between things. Again, if you had to drive in a icy storm, you might want to put some things into your car to weigh it down more. So that's pressing against the road harder and less likely to skid. Or better yet, get snow tires, which have really strong treads for gripping against the road. Now, snow tires are not great for gas mileage. You're supposed to take them off once the snow is gone, but they are effective in reducing friction, as are the soles of your shoes. That's their whole purpose, to keep you from slipping. So, in conclusion, friction is a force that opposes motion. It goes in the opposite direction of the motion. And it will, if there's no other force, if you push something and let it go and there's no more force pushing on it, friction is the thing that will slow it down. It's the reason why if you roll a ball down the street, it will eventually stop. There's 4 kinds of friction. There's static friction for objects that have not been moving for a while. That's the strongest one, that must be broken before you can get to sliding friction. Then there's rolling friction with tires, which is not as strong as the others. And then the weakest, fluid friction. Thank you very much.